Hey everybody, this is Alex Merced from alexmercedcoder.com, and I was just watching some videos over there from the YouTube channel Fun Fun Function, which is a really good YouTube channel. So I really highly recommend that you subscribe to it because it's really good. But what I want to do is do a series on advanced object-oriented programming in JavaScript and TypeScript. So the first couple of videos I'm going to be going over ideas that are applicable to JavaScript and TypeScript, and then in the end we're going to go over like TypeScript mixins, which is kind of more of an exclusively a TypeScript thing. So, but the idea is that this should start getting you to think a little bit more expansively about object-oriented programming and how you achieve that. Now, if you've seen any of the videos where I talk about classes in really for any programming language, I should have a video about classes in every language, or almost every language. I talk about the idea of inheritance and just sort of the way we think about object-oriented programming. So basically the idea is like you would create an animal class that defines what an animal is, and then that class would then inherit to a dog. So a dog would inherit the animal, and then you would add more detail to it, and you would create this sort of hierarchy of classes, and then you can instantiate those classes. And in most programming languages, that's how you have to do it. The reason being is that the way you create objects is you create a class first in most programming languages. But in JavaScript and TypeScript, it's the kind of the only one where you can pretty much do everything that a class would in a data structure called an object. Meaning you can actually put variables and functions inside the object data structure without having to create a class with a constructor and all that stuff. Most other languages, you have variables that can hold key value pairs, dictionaries, maps, but they don't necessarily hold functions inside of them. And I think in Go, you don't even have classes or objects. You have functions, and you have structs, which are kind of like a class, but with only variables. And you have to kind of mix the two. So how you do these things are different from language to language. But JavaScript offers you a lot of flexibility that you can find other ways to get the same thing done that might be more semantic, might be easier. So that's kind of what this series is going to be about. But first I want to introduce sort of the idea between what we're going to be focusing on here. So we're going to move away from sort of the design pattern. And when I say design pattern, meaning a method of solving things. There's a really good book that's usually referred to as the Gang of Four book that kind of goes through different ways of solving problems using object-oriented programming. Like how can you design your objects in a way that makes sense to solve the solution. And we're going to be focusing on a solution called factories in a moment. But inheritance is a pattern in the sense that you're creating a hierarchy of, you might be creating like this prototype class, which is like the animal class, that then becomes sort of the beginning blueprint for everything else. And that works, but the problem is you do run into a situation where sometimes this causes redundant code in the sense that what if you have two child classes that both would have the same sort of additional function, but it doesn't make sense for the parent to have that additional method because again, the child is inheriting everything of the parent. So if two of the children need the same, let's say, method, but you have 10 children, the other 8 children don't. So it doesn't make sense for the parent method to have that. So you have a couple different ways you can do it. You can kind of do another in-between parent function class, but then you have to go kind of refactor all your code. Or you can just take the approach of what's called composition. So instead of designing your classes and your objects based on what they are, what you do is you design a bunch of pieces on what they do, which is another design pattern. So what you do is you build out pieces. Or you build it out in a way that's, you basically assemble the pieces that you want. And there's a couple different ways of doing it. I'm going to explain the way that was explained in Fun Functions, but I'm also going to explain a way to do it with classes as well. Fun Functions explained it using objects, and I really liked that solution as well, but I want to make sure you have options. So essentially what you could do is, let's pretend I wanted to create a class for characters in a video game. So class, we'll call it VG car, like video game character. And I'm not going to give it any other properties other than it's what I know that every character is going to have. Constructor. So we'll declare actually just do it all in the constructor. Constructor. Okay, constructor. And we'll say that the constructor is going to take 3 parameters. Or actually a few parameters. We're going to take it name, health, strength, defense, spell 1, spell 2. Okay. So in this case, constructor. So then we'll just say this dot name equals name. And you guys get the idea. I'm going to just make this constructor that just kind of does this right down the board. Equals health. This dot strength equals strength. This dot defense equals defense. This dot spell 1 equals spell 1. And this dot spell 2 equals spell 2. So what I'm doing here is that instead of creating, my idea here conceptually is that instead of having to create a separate object every time, or a separate separate class. So instead of like I take this character, I take this template and then inherit it to create a fighter or a wizard or a druid or whatever kind of class. What I'm going to do instead is that instead of creating methods within the class, I'll pass the methods as parameters in the constructor. So that would basically I can add functionality by passing in whatnot, or I could even pass in an object with skill. So I can just basically, theoretically, I could just make all the methods an object that gets passed into the constructor, and then you just create like a bunch of different objects for different classes. So the idea is that this is just sort of a more modular way to kind of do this. Cool. So let's say I create a spell called const. So I'm creating this outside of the constructor. Notice I'm not creating this function inside the constructor. So const fireball equals arrow function console. I don't even need that. Console.log fireball. Then let's make another one. Const heal equals console.log fireball. Well, no, healing. Cool. So now if I want to create a new character, so we'll say const Bob equals new VG car. Okay, and then there's the constructor. So we'll say his name is Bob. His strength is 10. I don't need to type in strength. So 10, 10, 10. Then fireball heal. So I'm giving him his stats, and I'm saying what spells he has, and I have a character. So what I'm doing is that instead of defining all the individual methods for this individual class, I'm giving some slots to pass down a lot of the aspects of it. So I still have a class. There are some benefits to having a class speed-wise, but it shouldn't really matter for most programs, unless you're doing something really, where you're instantiating a lot. Okay, thousands and thousands instances pretty quickly. But I'm giving it the functionality I want, where I don't have to worry about a whole bunch of children classes that may end up being redundant, because there might be one character that has one class that has like fireball and heal, but another one has like heal and ice, and another one has ice and fire. But the problem is, now I have to write ice a second time because the parent class doesn't have any of those. I can just pass off my methods as in the constructor. So that's kind of what I'm doing here. So let's give it a shot. So let's see here. Let's have Bob use fireball and have Bob use heal. Actually, that's not how that's going to be. It's going to be spell 1 and spell 2. So Bob spell 1, Bob spell 2. So it might have made more sense to actually pass in the skills as an object, so we can have more semantic names, but this will work and illustrate the point. Save. Let's run the code. Node practice.ts. There you go, fireball heal. So now what I could do, the thing is that someone might just start throwing in, like if I were to just give this class as a library to somebody, they might just be giving any kind of function in there and start giving them all sorts of weird abilities. So suddenly now I have a fighter that can for some reason spin up a web server, and that would be weird. Okay, so this is where the idea of a factory comes in. The idea of a factory is, instead of letting people instantiate objects or classes directly, or create their objects directly through data structures like classes and objects, creating a function that creates it for them. One, to control the creation process, but two, to control the creation process, but also two, to resolve some of the, if you're not going to use inheritance, you're not going to use classes, this can reduce the need for them. So using the class that I already have, let's just create some classes through functions. Okay, we'll create like character classes. So const, let me just make one more spell, const ice equals, okay, console.log heal, console.log ice. Okay, and now we'll create some functions to create characters. So we'll say const a spellcaster is the function, equals, so I'm going to take one parameter, name. Because remember, that constructor I did before had to put in all those numbers and write down the spells. Let me make it easier for people who are using my library. So now I can do name, and then I just do all that stuff here. So maybe I will create an array of random numbers. So let me do that. Okay, so here are my stats. We'll call this my array stats. I need to use const or stats equals an array, and then we're going to do a random number for each one. So we're going to have a kind of floor, or it's math.floor equals math.random, and we'll say times 10. So that way it's a random number between 1 and 10. Okay, and then I'm just going to do that 3 times. I should have created a random function, but that's fine. So it'll create 3 random numbers between 1 and 10 to generate some random stats. And then what it'll do, it's going to return a new spellcaster. I mean, not a new spellcaster. Return a new VG character. And then we just fill in our constructor. So that would be name, and then it would be stats 1. Actually, I think I should be able to use the spread operator here. So I'll just do stats. So that'll actually just make it the 3 random numbers in the constructor, stats, and then the last one, and then so I got my 3 random numbers, and then I want the spells. So then I'm going to want the spellcaster, so I want it to be fireball and ice. So the person who's creating the class doesn't have to be now thinking about, okay, what spells does this have? It's already baked into the function. So now the person, if they want to make a new character, they just have to be like const bob equals spellcaster Bob. And the function will actually construct now, and then that function will assist in the construction process of creating them their character. Okay, and then we sit there and we do const, let's do console.log. Okay. And let's publish Bob's stats, because right now everything's public. So Bob Bob dot health, Bob dot strength, Bob dot defense, and then let's have Bob cast ice. Bob dot ice, well, actually still would be spelled 2. Okay, and save. Okay, you see it works, because when a constructor, say he created 3 random numbers, and then there are his stats, and he was able to cast an ice spell. So I can create now another class if I wanted to. So I can just literally copy and paste this function and say, hey, here's a new class called healer. Same deal, except now instead of fireball and ice, we're going to say he has heal and ice. So that way, instead of having to create a bunch of children classes, I just have this base class and I just add the functionality I want into the class through the constructor through a function. But I could even go a step further and use functions to do this. Okay? Because at the end of the day, like, if you know, objects are pretty much kind of weird encapsulated classes in JavaScript when you really think about it. So basically, it's an instance without a definition. So you can just define it each way. So I could do something like this. So instead of changing, I could just keep that, per se. And instead, we'll say return an object. And the object is going to look like this. Name property is going to equal the name parameter. Strength. Okay. And strength is going to equal, again, the first, well, we'll do it in order. Health will equal stats 0. Strength okay, strength is going to be stats 1, and defense will be stats 2. And then I can actually give the spells a name, fireball. Since I know that every time anyone uses this particular function, they're going to get the fireball spell, I can just call it fireball. So that way the name is more semantic. Fireball, although spell 1, spell 2 is, again, depending on how your program works, if you know sort of the flow of your program, it might be better to have just sort of a universal reference to the different abilities of the character. But this is illustrating the point. Heal. Fireball. Then this will be heal. Cool. So I assign that. It's the same. It's really, at the end of the day, the same thing. They have the same variables and the same stats. The only difference is like the two spells will have different names. Like if I wanted to, I could just still make it spell 1 and spell 2, and the previous code will still work. So spell 1, spell 2, and let's see here. If that's the case, I should be able to pretty much comment out my class now. Okay, and we'll comment out our second factory function. And this code should still run, because now I'm no longer instantiating a new class. So actually, let me get rid of that keyword new. I'm just returning an object that has the same features, the name, the different stats, the fireball function, etc. So should still work. Let's see here, return new. But I thought I didn't save. There we go. So 3 random stats, and then he casted the heal spell. Okay, so spellcaster Bob, return an object. Now Bob represents that object, and console.log Bob health strength, and Bob ran the spell 2, which was heal, so it says heal. So you can achieve the same result, but you don't have to do the extra step of creating this class. And then you can just sit there and literally just create different functions for different possibilities. And you can pre-create your objects. Okay, so you can create all your spells, create all the different pieces, and then just assemble them in your factory functions. That'll just return an object that is essentially the same thing as a class. Okay, in this way, all your pieces can be separately, and you just assemble them as needed. Because with classes, you kind of have to pre-assume how they're going to be assembled together. I mean, there are ways to give flexibility, like I did before, where I created the slots to pass through certain pieces. But if you're going to disassemble all your pieces, you might as well just keep them disassembled, have all your functions separate, and then you just assemble the different properties and functions within this sort of object, key pair value type object. Okay, and again, you're not having to define so many classes, and you're not going to have to redefine functions, because 2 children classes end up having to duplicate a method that doesn't make sense to have in the parent class. So that's sort of the benefit of like the factory method in this type of design pattern, where instead of, and again, this doesn't necessarily exist in other programming languages. In other programming languages, you probably would have to take this first approach, where you create a more flexible constructor in your class, which is why I wanted to kind of show that method, because if you're operating in another programming language, you may still want that kind of flexibility, and you still may want to use factory functions, but you may have to do something more like this, where it's returning a new instance of the class instead of returning a JavaScript object like this. Cool. So that's sort of the idea. And again, this is referred to as, so this type of function is called a factory function. This type of method of creating your objects is referred to as composition, where I'm not thinking of what my object is. I'm not creating a fireball for a particular class. I'm creating these as pieces that different classes may need. So I'm creating all the different pieces that my different classes will need and then assembling them. So I'm looking at the composition of my objects instead of what they are. The encapsulating a concept, I'm encapsulating functionality, and then assigning the functionality I need to different functions. In TypeScript, there are different ways you can kind of do that. I think decorators are one way you can do that, but decorators are still an experimental feature in TypeScript. But we will cover decorators in my TypeScript tutorial video series eventually. And then there's mixins, where you can combine classes, and I'll be doing that in the next video. But this, and then if you're using TypeScript, you can type a lot of this stuff, so that way you can make sure that people use it right. So that way you can use this type of design pattern, but make sure that, hey, this is going to be a string. So I can be like, okay, well, you can only pass in a string, and you can only pass in an object that has these abilities, to make sure that it's always used in the right way. So that is that. I'll see you guys in the next video. Have a great day and enjoy.